Today we're going to talk about graphing linear equations in slope-intercept form. So we are jumping from 3.3 to 3.5, and this is a section that you probably learned a lot about in 8th grade. So the first thing we're going to talk about is the formula for slope. If you recall, slope of a line is rise over run. It is your change in y's over your change in x's, and the mathematical symbol for change is a triangle. And if you remember, has an equation to actually calculate the slope. It is your y2 minus y1 over x2 minus x1. So if you recall, those are all kind of three different ways to talk about slope. There are four kinds of slope. So the first type of slope is positive. So it's like you are standing at the bottom of a hill and you are walking uphill. And you always think about that from left to right. So this is a positive slope. This one over here would be as if you are walking downhill from left to right. This has a negative slope. This line right here that goes straight across is called a horizontal line. And every horizontal line is a y equals a number. Y equals 2, y equals 8, y equals -4. And every horizontal line has a slope of 0. And then this is a vertical line. Every vertical line has an equation of x equals. And anytime you have an x equals, the slope of a vertical line is what we call undefined. So these are the four different types of slopes you could have for lines. So if you take a look at our first example here, it says to describe the slope and then find it. If you notice right away, this is a vertical line, so the slope here on number 1 will be undefined. Number 2, if you look, you are walking uphill. So if you take a look at this problem, you're walking uphill, so this slope will be positive. But then you actually have to calculate it. There are lots of different ways of calculating it. One way is to take your 2 points and use your slope formula. So we call this x1, y1, x2, y2. And your slope formula said y2, 4, minus y1, which is -4, over x2, which is 3, minus x1, which is -1. Because the two negatives right here are right next to each other, you zip-zap those, and 4 plus 4 is 8. Same thing here, because they are right next to each other here, you zip-zap those. 3 plus 1 is 4. 8 divided by 4 is 2, so this has a slope of 2. The other way you could have done that is you could have found 2 nice points on your graph where they cross, and you could have just done it by counting. Slope is always rise over run. So if you look here, from left to right, I go up 2, right 1. So that's a positive 2 over a positive 1, which in that case would just be 2. For my next example, you will see that this is a negative slope because you are walking downhill. The first way you could have found the slope is using the slope formula. The second way is you find some nice points on that line, and the nice points can actually be anywhere. And all you have to do is move from one point to the other point. So if I start here, I'm going down 1, which is a -1, and then right 1, which is a +1. So in this case, my slope was to be -1. If I wanted to use my slope formula, I take my first point and call it x1, y1. My second point, call it x2, y2, and you can call whatever point x1 and y1 and whatever point x2, y2. And then I start with y2, -2, minus y1, which is 3, over x2, which is 3, minus x1, which is a -2. So in this case, I get -5. I zip-zap those over +5, and again, that's the same as -1. So my next example, we are talking about a table. Whenever you have a table and you are asked to calculate the slope, you just pick 2 points on that table and use your slope formula. So in this case, I'm going to pick the point 1, -2, and I'm going to pick the point 2, -2. And then I can call this one x1, y1, x2, y2, and I can calculate my slope. y2, -2, minus y1, which is a -2, over x2, 2, minus x1, 1. And what I do on top is I zip zap that. I get 0. 2 minus 1 is 1. 0 divided by anything is 0. On this problem, I would list the points, whatever points I choose. I'm going to choose negative 3, 11. And I'm going to choose negative 1, 3. This is x1, y1. This is x2, y2. So I start with my y2, 3, minus my y1, which is 11, over my x2, negative 1, minus my x1, which is negative 3. On top, I get negative 8, and on the bottom, I zip zap, I get 2. My slope here is a negative 4. The next thing we're going to look at is we are going to look at slope-intercept form for writing a line. So anytime you need to write an equation for a line in slope-intercept form, it takes the form y equals mx plus b, where the m is your slope and the b is your y-intercept. So if you take a look at our first example, it's quite easy if it's already written in slope-intercept form. So in this case, I have y equals mx plus b. So my slope is the number in front of the x, and my y-intercept is the number at the end. It's a little bit harder when it is not written in that form or it's a different type of line. If you remember from before, in this equation it is x equals 12. Anytime you have an x equals without a y involved, it is a vertical line. So this would be x equals 12 would be a vertical line crossing your x-axis at 12. So in this case, once you see that it is a vertical line, you will notice that your slope is undefined. And if you look here, any vertical line but one will never ever cross your y-axis. So because my vertical line is way out here, there is no y-intercept. Let's try a different one. This case, I have an equation for a line, a linear function again, but it is not written in slope-intercept form. So what I'm going to do is I'm going to get it to slope-intercept form. So in order to do that, I have to get y by itself. So in order to get y by itself, I'm going to subtract 6x. So I bring that to the other side. So I have 4y equals, I cannot put these together because one has a variable and one does not, so they are not like terms, equals negative 6x plus 24. And then I'm going to divide by 4. Once I do that, I have y equals negative 6 over 4 can reduce to negative 3 over 2x plus 6. Once it's in slope-intercept form, I can then get my slope as the number in front of the x and my y-intercept. The next example is again not written in slope-intercept form, but we're going to get it in slope-intercept form. So in this case, I'm going to get y by itself by subtracting 2x. So I have negative 3y equals negative 2x plus 9. Then I'm going to divide by negative 3. And I'm going to end up with y equals, two negatives make a positive, 2/3 x. 9 divided by negative 3 is a negative 3. So my slope is 2/3, and my y-intercept is negative 3. On the next example, we again do not have y alone, but we can get y alone. So in this case, I'm going to subtract the 1. So I have 4x minus 1 equals negative 2y. Then I'm going to divide each part by negative 2. And I'm going to get y equals 4 divided by negative 2 is a negative 2x. These two negatives make that a plus 1/2. My slope then is negative 2, and my y-intercept is 1/2. And then we have our last one, which has a bunch of stuff, but we're still going to do it the same way as we did by getting y alone. So I'm going to subtract my 3. So then I have 2 equals negative x plus 6y. Then I'm going to add x. So I have x plus 2 equals 6y. And then I'm going to divide each part by 6. and I have y equals x over 6 plus 6 reduces to 1/3. And once I do that, I can look at my slope. If there's not a number on top, I can make a 1. So my slope here is 1/6, and my y-intercept is 1/3. So the last thing we're going to do is we're going to look at some of these linear functions and kind of some word relationship problems. So this says a linear function f models a relationship in which the dependent, or y, decreases 6. For every 3 units, the independent decreases. So for every 3 units, the x decreases. So if you recall, your kind of definition of slope is change in y's over change in x's. So in order to get the slope here, you have to find what is happening with your y's and put that on top over what is happening with your x's. So your dependent, or y's, decrease by 6. So they go down 6 or -6. For every 3 units, the independent, or x, decreases. So your change in y's over your change in x's gives you a slope of 2. Now it says the value of the function at 0 is 4. So if you think of the point at 0, your value is 4, you just found your y-intercept. Because your y-intercept is when your x is 0 or when it crosses your y-axis, so your y-intercept is 4. So in order to graph this, you have a y-intercept of 4 and a slope of 2. So you go up 2 over 1, up 2 over 1, or you could go down 2, back 1, and that is your equation for your line. Let's take a look at another one. And in this case, just in case you wanted to write an equation, you could write your equation like that. Number 13, a linear function h models a relationship in which the dependent, or y, value decreases 2 for every 5 units the independent variable increases. So in order to get the slope, my y values, or dependent values, decrease by 2 for every 5 my independent, or x, increase. So my slope is going to be -2 over 5. The next thing, the value of the function at 0 is 3. So at 0, when x is 0, y is 3. So that also gives you your y-intercept here to be 3.